So we're going to move on to the next speaker,
Thank you very
Vasile
much.
Patrascu. Thank you so much again, Dr. Chakrabarty.
Thank you. Bye-bye.
So let me spotlight. Give me a second to find him. Oh, found. Awesome. Everyone, please welcome Vasile Patrascu. He's a principal engineer at Jitterbit, responsible for driving the design and implementation of the next generation of cloud integration products. A lot of words. Vasile Patrascu graduated with a bachelor's in computer science from the University of Bucharest and went on to work as a senior technical lead at IBM and Cast Iron Systems. Without further ado, please take it away, Vasile Patrascu. We can't hear you. You're muted.
I'm sorry. I've been using the Zoom product and I'm still making the same mistake. So thank you, Diana, for the wonderful introduction. It's 2 o'clock Sunday Pacific time. Thank you everyone for sticking around, and also a big shout out to the organizer for putting together this this wonderful conference, and big shout out especially to Diana. I put together a few slides so that we can have a context to talk about what does it mean to, how does the life of a full stack developer look like, right? And hopefully we'll have some question at the end. Let me go ahead and share some of the presentation. All right. Hopefully, yeah. Okay, so you guys can share. Just a quick introduction for myself. Obviously, principal engineer at Jitterbit with more than 20 years experience. Jitterbit, it's a data integration company that basically moves data between various systems. So I have a little agenda that I want to talk about. So the first one is how do I get into computer science? I'll just spend a few minutes, and then I would like to talk about life as a full stack developer. And usually I would like to talk about a typical day. What is a typical day as a full stack developer? And as part of this topic, I will also cover what is a full stack. And this is just my view. What does it mean to work on a full stack? What actually a full stack is, which I'm sure everyone knows what a full stack is, but what really is, what are the components? And then hopefully we're gonna have enough time for Q&A. How are we doing on the time?
So right now we're like 45 minutes behind, but you can take.
All right.
Yeah, you can just take as much time.
So how they got into CS, into computer science, right? Everyone experienced in how they got into a career. It's obviously unique. And I would like to say that, hey, computer science chose me, but that is not true. And to be honest, I don't even remember when I was asked this question. When was the last time, actually, or even if I asked this question. But regardless, I had to dig into the memory to figure out how they got here, actually. And I think everything starts for me with middle school. When I started middle school, actually, I wasn't very good at math. But I had an amazing teacher, and she was very good at she's very good at inspire a lot of passion into you and get the best out of you and get the best out of me when coming to math. And by the time I finished the middle school, I was really good at math. I enjoy solving problems, and the same passion carried over to the high school. However, as I got into the junior and senior year, what did I wanted to do was becoming fuzzier and fuzzier. But one thing that I knew that I want to follow on the math path, but also I knew that I didn't want to follow other career like being a biologist, follow medicine, or being a lawyer. By the time I got into college and got accepted to the math faculty, it just happened that I think a few years before they added a new major, was called informatics, which is the equivalent of computer science. And I had to decide the end of the first year to decide if I want to continue on the math path and follow a career in teaching or maybe researching, or actually switch to the computer science. I knew that I didn't want to follow, again, didn't want to follow a career path into teaching. So now you have to imagine that this is the end of the year. I've seen computers only in movies and probably had no idea how to turn off a computer. And I still made a decision to actually go the computer science and switch the major. And obviously I realized that being relatively new, this is going to open up a lot of opportunities, but also it's something that was challenging to me, something that I haven't done before. And that's how I got into. I mean, the big takeaways is sometimes knowing what you do not want to do, what career you do not want to follow is it's as important as knowing what you want to do, what career you want to follow. And obviously, what I would say is be open to opportunities, be open to challenges. You may not know now, but you will figure out later. All right, so let's go to the next slide. So I want to talk about the full stack developer in a typical day. But before that, let's talk about the full stack. What is a full stack? In general, a full stack represents all the components, all the layers that make up an application. When we're talking about application, it's really referring to a web-based application. And usually people, when they refer to a full stack, they refer to the front end, and where actually, you're doing the UI of the application, and then they're referring to the back end. Now, but I want to explore a little bit those two layers and dive a little bit more into and see what kind of technology actually are being used at every layer. So you have at the top of the stack, you obviously have an application. Usually it's a web-based application that uses HTML, CSS, JavaScript technology. This application actually can be packaged as a mobile app, or can be packaged as a desktop application, or even you can access it through the browser. And one sample of such application, which I'm sure everyone is using, is Slack, right? Everyone is using Slack. You can go on your phone, you can download it. You can go on your on the desktop, download it as a desktop app. What behind the scene, the application itself, even though it seems, when you download it on your phone, it's a mobile application. In reality, it's built using the HTML, CSS, JavaScript technology. Now, in the recent year, the developers actually, they start using frameworks like Angular that allows you to develop what we call single-page apps. And those single-page apps actually mimics the desktop application behaviors, right? So that's one of the things that it's happening, and that's really what the industry is going to. Now, as you go down the stack, there is the app server. This is really where the business logic of the application gets encapsulated. Usually you would use the same language, right? The one that you use for the web-based application, for the above layer. For example, in our case, we're using Java. We're using TypeScript and Angular for the application layer, for the web-based application layer or the UI layer, but also we're using JavaScript and TypeScript for the app server layer or the backend. Definitely, it's not a requirement. Others are using Java. Depends on the requirements, or they're using languages like Python, PHP, or even Go. Now, as you go down, there's another layer that not a lot of people talk about it. This is what I call the data store layer. Usually, where you're storing data either for a short period of time, or you store it for a longer period of time. As part of the data store layer, you might have messaging layer, which it's in general it's used for storing messages for a short period of time, and it's storing for in queuing tasks maybe, or you want to check out later. It's also used for communicating with other services in your stack. So your app servers actually, it's a series of services, and those services needs to talk to each other. You might have a login service to allow the user to log in. You might have another service that does the credentials. Those applications may use the messaging layer to communicate among each other. As part of this data store layer, you might have a cache layer for performance boost. And in general, the cache layer will store the most used data that application uses. And this data will be stored in memory. And of course, if you want to store data for a longer time, you would use a database. Usually you'd use either a traditional database like a SQL database. If your model, if your data is modeled as a relational model, or if, for example, if you want to support high volume transaction, you'd use something like a NoSQL database like MongoDB or so. If your application has a need for search, you probably most likely end up using something like Elasticsearch database, which is a NoSQL database, and it's very suitable for searches. So this is the data store layer. And as you go down, obviously you need to run all these things somewhere, and usually you deploy to an infrastructure, right? To one of the cloud providers like AWS or GCP or Azure. Most of the developers actually like to run the entire things on their local computer if possible. Sometimes it's not possible, but most of the time it's possible, and they'll make it happen. So you can think about, now you can think about the full. So the general notion is that the full stack developer will work only on the top two layers, the web-based application and the app servers, but also they need to have knowledge about data store. They need to have knowledge about infrastructure and how to deploy their application and so on. All right. Let's see. I'm going to stop for a second, see if there are any questions. In case there are questions, I'm more than happy to answer as you go. If not, it's extremely hot in California today, and the air conditioning is not working the way it's supposed to. All right, so let's get going. A typical day. Well, before starting actually talking about a typical day, just want to mention a couple of things. Our development team, the one that I'm part of, we follow the agile software development, specifically Scrum. And Agile, also known as Agile, you're probably going to hear that. This really has been adopted by the industry a few years back. Before that used to be the waterfall model, which now is not used anymore. But Agile is really focusing on individuals' interaction over processes and tools, customer collaboration, and responding to changes. We are using Scrum, which is the framework in which our dev teams, our development team operates. And probably this is the standard anywhere you go in the industry. And usually the Scrum team will be made of the product owners, or we call them stakeholders, and of course the dev team, and sometimes you'd have a Scrum master. And usually the Scrum starts with, planning. When you're planning, you as an individual contributor, you're committing to certain tasks to be done during the sprint, and sprint lasts for about, on average, 2 weeks. In our case, it's 3 weeks. And at the end of the sprint, you'll have a release so that you can get the features to the customer sooner than later. You have a retrospective where you talk about things that, hey, what worked, what didn't work, how can you improve? And of course, things that you haven't been able to finish will go in a backlog. So those are kind of I would say, the framework in which our development team operates. And in most situations, all the development teams operates in those two frameworks, subscribing to Agile methodology, and also using Scrum as the framework to really operate. And it's all about being as nimble as possible. How can we deliver features quickly to our customer? How can we be predictable in the things that we're doing? So we know when we check in the sprint, yes, this is where we are, and we can commit the features to the customer in the time given. Now, let's talk about a typical day. This is really what a typical day looks like for most of the developers, I would say. It may sound boring, but there's a lot of things, obviously a lot of nuances that that probably are not captured here, but I'll try to capture them as much as I can. So we start with daily scrum, also called daily stand-up. Usually this is, when the team gathers, give status, what you've done yesterday, which task have you worked, and what you'll do today, right? What task you're going to work on, any issues that needs to be addressed. And usually, if there are any issues, those we're gonna talk about them at the end of the daily scrum. And usually I moderate those discussions so that we can get to the right solution. Most of the time, after the stand up, there is a sprint progress where we're keeping track of the progress using Jira. As a team, you have to know where you are in the sprint. You have to, you have to know if you can deliver what you committed to. So, or if in certain situation you have to adjust and actually change the plan, you have to be agile. And then everybody goes about the day. They start developing and working on their task. So they may write code. People, in our case, we're writing code on the front end. We're using Angular and TypeScript. For those of you who doesn't know what TypeScript is, it's really a superset of JavaScript, very similar, but it's typed. Obviously, Angular, it's a web framework that is being very popular. It's one of the popular frameworks out there. Angular, React, Vue, I've seen, but definitely Angular. It's one of the popular one made by, I believe, Google. And then on the back end, you would use the same thing. You write code for the back end using the same technology, TypeScript. Sometimes you have to do Java or maybe other languages like C++. Just as a side note, anyone who wants to go into computer science, most likely they're going to learn and use more than one programming languages. The important thing is once you learn one language and once you learn the fundamentals and the concepts, everything is coming natural to learn. And the interesting thing is that even though they are different, sometimes you have to, when you're writing code in a specific language, you have to write code the way the language has been designed to. The same way you speak in a language, right? All right, so, and then obviously after writing code, there is the part where every code that you write has to be unit testable, and making sure that all the scenarios are covered. By the time it gets to the customer, your code is bug-free. The reality is that's not necessarily true. You may have situations when things are slipping away. And then, of course, testing whatever feature you work on, whatever bug have you fixed has to be as well unit tested and tested. Let's see. This is an interesting thing. If you're running into issues, if you're running into a problem, usually what we do, we ask help on Slack, right? Like anyone else. Most likely, the interesting thing is that if you're running into a problem that nobody can help you from your team, probably somebody else have already run into, and there is a good chance that you may find an answer if you either using the search engine or if you go to Stack Overflow. So the search engine, without naming one, is probably one of your best. Is going to become one of your best friends. But the trick is you have to know what is it that you look for. The search engine can help you so much, but if you don't know what you're looking for, then it's going to be a problem. Obviously, the collaboration between the team happens on Zoom and Slack. There's a lot of things that we need to talk about, especially today when remote work has becoming, or actually when the work has become remote, it's becoming more imperative, the collaboration, and we're trying to stay in contact using those two technology. And the other thing is going to happen is that once you're done with your work, what's happening? Well, usually you want your work to go in the main branch so that it's going to go to, eventually it's going to get released and the customer is going to see the changes. There's a process where you're doing the pull request. Those of you familiar with GitHub, probably already familiar with the pull request, where you asking essentially your changes to get into the main branch. Those needs to be reviewed by your peers, and once they get reviewed, they will get merged, and there is a process that the team has built where things are getting automatically deployed and pushed to one of our environments for either testing or releasing. And then, of course, there is meetings. We try to keep those meetings at minimal so that the work is not disrupted. Writing code, it is a creative work and requires a lot of skills. And we try not to interrupt somebody because you have to switch contexts. Just think about it. One thing can be written by multiple guys different ways. So it's really a creative work. We try to keep meetings as minimal as possible. It's not always possible, but that's kind of a typical day. And let's see. All right, I have one more slide that I want to talk about it. So it looks like I'm on time. Actually, I wanted to allocate about 10 minutes for Q&A and see if there are any questions. Let me talk about the next slide, and then we're gonna go to the Q&A. Usually for me, there is a non-typical day as well, where there is things that I have to take care of. But that's because besides the normal responsibilities as a full stack, also I have other responsibilities. Obviously, customer interaction is important. Without customer feedback, you wouldn't know, and you wouldn't know how to prioritize the improvements on your product, right? You want your customers to be happy and enjoy using your product. Another responsibility is architecture. I'm responsible for the architecture of the stack. Stack is something that evolves constantly. There's always room for improvements, and there is things that you have to answer. Can the stack auto scale when there is a spike, when there is a load of the number of requests of the volume, when the volume of transaction increases? Is the stack reliable? What happened when, for example, one of the layer doesn't work? The database, you can't communicate with the database. Are you able to still properly return a response to the application? All these are important things that we have to take care of. If there is an outage, right? How do we know? How do you notify the customers? Are you getting notification? So those are all things that we have to take care of, and of course, and be on top of it. Things like the stack. Can the stack self-heal itself when there is an issue? Those are important things that we have to answer, and we have to make sure that we are ahead of the curve. The other thing is, which I think is very important, how do you keep up to date? The tech industry, especially in the Valley, it's a very competitive industry, and changes extremely fast. And it is important. It is important to see where the industry is going. What's the trend? You may not notice, but definitely, just I want to say Slack, probably Zoom wasn't around 20 years ago, and in less than, probably was around 7 years ago, maybe 10 years ago, and just in a few years everything changed. So the way we do it is, you gotta read a lot. You gotta go to conferences, make connection with other people. When you go to conferences, see what problem they run into, how they solve, exchange experience, figure out what's new on the market, and learn as much as you can from other experiences. Blogs also, it's another things where you can learn a lot of things. If you run into an issue and you Google it, to figure out what other people have solved it, most likely you're going to end up reading a blog, and suddenly it's like, yeah, there are some other people that most likely are smarter than you, and there's no shame in actually learning from those folks as well. And of course, there is Meetup, there is friends in the industry that is sharing this information with, and so on. And the last thing is mentorship and leadership. My team, or our team, I would say, it's a very young team, a brilliant team. They graduated, maybe a couple of guys, they graduated a year ago, others they graduated 3 or 4 years ago. You have to really work with them and mentor them and help them with their career and achieve their goals as well, right? There's one thing that I've learned, and I don't know who said that. There is no compression algorithm for experience. That's something you cannot compress, and you just have to go to those stages to get to where you want it. And um, at least share your experience. The guys that have more experience than others, share your experience with them, and so that they can learn. That's kind of what I have as far as, oh, okay, so I'm on time, 20 minutes. Now I'm just gonna do a Q&A, since if there are any question and answer that I could,
I actually have a question, but before I ask it, Dr. Graham, are you here? Is he here? I think.
Yes, hello.
Oh, hi. Okay. Just give us a few minutes for questions, and then we'll transition to Dr. Graham.
Thank you.
Okay. Oh, okay. My question was, how many hours do you code a day, like on average?
I wish it would be an average. I get that asked a lot. It's sometimes could be 10 hours, sometimes could be 1 hour. It's, sometimes could be inspired and you're not going to leave the computer until you finish what you started. Again, coding, it's a creative work. I almost consider it's like an art, right? And you have to apply the same discipline, the same skills. You have to be disciplined. You have to practice good habits, because the tendency is of the human behavior. Yeah, just, I'm going to come back. But most importantly, it's a creative work. And when you're inspired, I tend to actually finish the entire thing that I propose to finish. And usually I don't like to, but that's personal, to leave things halfway done, because I may lose my thought. That's really at least my concern.
I have a question also. So if I want to find people, or if one wants to find people, like a team per se, to help students or high schoolers or parents with like development and these types of things, how available are people to do it? These types of things, depending on the project.
It depends on the project, and
more specifically, like LLVM compilers.
LLVM. What's LLVM?
It's a form for compiling.
It's
an infrastructure.
LLVM, you said?
Yes.
LLVM. Okay, yeah. I know what LLVM is. Okay. So the best thing that you can do is, at least what I find out, is follow the open source project model. You'd go on GitHub. That's probably the best place where you open a project, your repository, and you'll find people that they want to help. If they find your idea interested, they will join your project, and that's the best way to collaborate. As a matter of fact, just my saying is that open source project is the best model. It's probably, without open source, the industry would have not been where it is today. That's the reality. When I started, I mean, open source, the biggest open source project was actually, what was it? Linux. That was the one, yeah. But yeah, that's the model. That's the way you probably want to do it, and you'll find people to join you, and from industry and others, other students, either from college or from high school. But you will find there's no limit there.
Yeah. Thank you.
Vasi, can you see the chat?
Oh.
I can just read them off. I know you're screen sharing.
All right, I can see. All right, so let's see. How did you do to better your coding skills? Well, that's actually an excellent question. You gotta practice a lot. You gotta learn. You gotta read a lot. and you got to steal from others. That's the best thing to do. Steal from others. Steal, if you find a mentor, steal from there. It's the same that I do now. It's, you know, the younger team in my team, they stealing from me. They learning how to do things. They learning about best practices. They learning about design patterns that they need to apply in each situation. And that's probably the best way to do it. What do you think is the most rewarding part of your profession? Oh, that's an excellent question. The most rewarding part, the most rewarding parts. Okay, so when customer using your product and they enjoy it, and they come to you and say, "Hey, I enjoy using your product. It helped me a lot." That's probably the best reward that I can ever get. That's really the best reward, bar none, because ultimately what you're building for somebody else, not necessarily for you. You're building to help somebody. Let me see. And I'm not sure if that's the complete answer for the rewarding part, but this is one of the things that are really, really, it is rewarding for me, the customer feedback. What is different between programmer and software engineer? I don't think there is any difference between programmer and software engineer. In my opinion, it's the same thing. You still have to do the same chores. There's no difference. I think enterprises, they may have different titles in their company, but ultimately it's the same thing. Between Angular, React, and Vue, which is a better framework to learn? If I say jQuery would be a better one, is that a better answer? No, I'm kidding, of course. All of them are good, are very good frameworks. Angular, it's one of the popular out there. It's a little bit more complicated. I think the learning curve for Angular, it's steeper than the learning curve for React and Vue. And I think if you don't have the patience and if you want to see something quickly, the best way is to start with probably, I would say, even though I haven't used myself React, but you could start with React, which is a little simpler. And their programming model, it's definitely simplified. Angular, it's a little, again, it's the learning curve, but both of them are extremely powerful. And Vue as well, actually. I've heard a lot of good things about Vue. What do you think is the best useful coding language to learn? Coding language to learn, what is the best useful? There isn't one. Once you're learning one language, it's going to be easy to learn the second one. The best thing that you can do is focus on learning the fundamentals, the concepts of computer science. Learn about algorithms, excuse me, learns about data structures, learns about those basic things. Well, actually, they are not basic. They are really, you need them. Those are part of your tools when you're going to go in a software engineering. If you're going to go as a software engineer, those are just part of your tools. The language is just the tools that you're using for doing something. For example, JavaScript, it's very good if you're doing web application. It's not extremely good if you're doing let's say CPU intensive application. You probably use a different language for that, either Java or C or C++. But I would say if I were to start again, and I think, well, actually no, when I was in college, when I started actually with C. And the reason I started with C was that once you learn C and learned about the concepts, you learn about memory allocation, you learn about how to destroy, deallocate memory, you learn about pointers. Those are basic concepts that is going to help you with any programming language. All right. Any other questions? Okay.
Yes. I would like to ask, if you are starting a business or you want to start a business, do you think there are some ways to integrate coding into your business, or are there ways to make coding itself into a business?
So let me see if I understand correctly. If you're starting a business, is there any way to use coding into the business? Is that what you're asking?
Yes.
Well, it depends on the business. Again, is it high-tech business? Is it a business that, let's say, the domain is different than high-tech? Maybe, I don't know. Just give me an example of a business. Let's say if it's, I'm just trying to think, a shoe shop, right? A specific shoe shop that does a specific sneakers for sports. I'm a big fan of sports, so I'm using that analogy. Probably you only use the coding just as a tool to help you grow the business, but the main business is the shoes, the sneakers, not necessarily the coding, right? Does it make sense?
Yeah.
Maybe I don't understand the question. What was the second?
That was a good answer. Yeah, thank you.
All right. Okay. Let's see. All right. So, all right. So it looks like there are no more questions. Thank you so much for sticking around. And great question, guys. Really great question. And by the way, I love all the talks.
All right. Thank you so much.
Thank you.